Okay. In the last class, I started property 6 and did mistake. See, the property 6 is there is no any sequence for remembering this property 1, 2, 3. It's a it's an application of that particular determinant. Let A equal to A is a square matrix, B a square matrix, order n. Let B is a matrix obtained from A by multiplying each element of a row or column of A by a scalar k. Then determinant of B equal to k of determinant of A. Suppose let A equal to A, B, C, D. Then B is the multiple of K with only one row or column, KC, KD. Now the determinant of A is AD minus BC. Now what about determinant of B? A into KD minus B into KC. So you can take the common AD minus BC. This is the determinant of A. See how the beauty of the properties of the determinant. Next property is property let 7. Now in this property, suppose if a matrix like A1 plus K1, B1 plus K2, C1 plus K3, A2, B2, C2, A3, B3, C3. Let the determinant of A is A1 plus K1, B1 plus K2, C1 plus K3, A2, B2, C2, A3, B3, C3. Can also be written as, or we can split this it into A1, B1, C1, A2, B2, C2, A3, B3, C3 plus K1, K2, K3, A2, B2, C2, A3, B3, C3. This way you can write and find the determinant and individually, and then you can add that, then you will get the original one. Next property is let A be a square matrix and B be a matrix obtained from A, adding to a row of A. Let's first write the property. Let A be a square matrix and B be a matrix obtained from A by adding to a row or column of A scalar multiple of another row of A, then determinant of A equal to determinant of B. See again, read it carefully. Let A be a square matrix and B a matrix obtained from A by adding to a row of a scalar multiple of another row. Let us see. Let A is A1, B1, C1, A2, B2, C2, A3, B3, C3. And from that, let scalar multiple is K and multiply one of the row or column and add the first one or second one, or that is A1, A2, A3 plus or minus. You can KB1 plus KB2, KB3, B1, B2, B3, C1, C2, C3. These two are same. Determinant of A equal to determinant of B. You can prove it. See, this can be written as, let B is A1, B1, C1, A2, B2, C2, A3, B3, C3 plus K of, or let this is by using the previous property KB1, KB2, KB3, sorry, B3, let B1, B2, B3, C1, C2, C3. If you take common K in this row of a matrix A1, B1, C1, A2, B2, C2, A3, B3, C3 plus you can take the common take the common of a number from one entire one row or entire one column. This is B1, B1, C1, B2, B2, C2, B3, B3, C3. See, these two columns are equal. So in any determinant, if two columns are rows are equal, then this becomes 0. Determinant of that become 0. We already saw. So plus k into 0. This becomes, this way you can easily do whatever you want. Let the next property is, if any row of or column of a matrix 0, that determinant becomes 0. Let 0, 0, 0, A2, B2, C2, A3, B3, C3. No, determinant of A is 0. You can check. Okay. Okay, now next property is, if A and B are square matrix of the same order, then determinant of AB equal to determinant of A into determinant of B. So this way you can easily find the determinant of any matrix or any matrix. Now you see some examples in the next video.